in DBMS concepts, we have one topic that is relational model.
Okay.
Yeah, relation or relation is nothing but it is a table. Basically, what is a table? You have any idea about that?
Relation. Yeah, table.
Yeah, table means generally what we can say a table.
Um,
The table is nothing but it is a collection of rows and columns. So in the relational model topic, we are going to discuss about how we are going to organize the data in the form of tables. Next one, how these tables are stored in the databases. Next, what are the various keys are there in the tables? Example, primary key, private key, candidate key, like that. Next one, what
foreign
are the
key.
various, yeah, foreign key, all these. So in the tables, what are the attributes we can say keys that we will discuss. Now, if you see first one, what is relation? Just now we discussed relation is a collection of rows and columns. Here, rows are nothing but, see, rows are nothing but, what is the another name for row? Tuple. Another name for the row is tuple. Tuple is nothing but row. See, now if you observe here carefully, we have tuple here and attributes also. Attributes are there. Attributes are nothing but columns. Just I am going to share the screen. See, you can see screen image is visible.
Yeah, yeah.
Yeah, see here we have table with various attributes. Attributes are nothing but columns. Rows are nothing but tuples. Please keep in mind that. First one is ID. First column name or first attribute name is ID. Second one is name. Third one is department name. Fourth one is salary. How many attributes
Mm,
are there here?
4.
Very good. Next, here various rows also there. So ID, name, department, all this. This is the general example of a relation. We need to take a table. From that table, we need to organize rows and columns. Any doubt in that diagram?
No, no.
Fine. A1 comma A2 and so on up to AN are attributes. So you can work with not only limited number of columns, you can work with n number of columns. That is nothing but up to AN. So here R is equal to, R is nothing but relation which is called a table. A1 comma A2 and so on AN is a relation schema. Simply we can say. So now if you observe here, what are the attributes are there that we need to mention? ID, comma, name, department name, salary. See, a relation R defined over schema R is denoted by R of R. Please try to understand here. R is a relation, capital R is a schema. Try to understand. Relation is, schema is part of a relation. The current values a relation are specified by a table. So what are the various columns and values are there? Values means rows. All will be represented in the relations. An element T of relation R. Are you able to understand?
Yeah.
Yeah, good. An element T. See here, T is nothing but a tuple of relation R. Means R means relation, T means tuple. In the table, T is nothing but a tuple and is represented a row in a table. Now, what is the another name for row? Tell me, Ananya.
Attr
Your name is Ananya only.
Yeah, yeah.
Yeah, tell me, what is another name for row?
Tuple.
Tuple. What is the another name for column?
Attributes.
Fine. See, next one, that's it about rows. Next one is attributes. The set of allowed values for each attribute is called the domain of the attribute. Please try to understand here. What are the values we have for the attributes that are nothing but domains? Suppose you got a job, everyone will ask in which domain you got a job. That is your value of job. That means your status of a job. Your job information. Domain means your job platform. Same like that. What are the values are there for the attributes that are called domains? Attribute values are normally required to be atomic. What is atomic? Indivisible. See here, it is not possible to devise, indivisible. The special value null is a member of every domain. Please understand here. Null means what? Unknown value. Null, simply null we can say unknown value. Null indicates unknown value. The null value causes complications in the definition of many operations. So whenever unknown values are there, automatically if you want to substitute any value, that value itself unknown means it is not possible to substitute that value. Understood, Ananya?
Yeah.
See, for any attribute, if there is no value, obviously it is not possible to substitute that value in any equation. That's why null always creates complications. Next one is relations are unordered. Please try to unordered means
It's not in an order.
very good. That means irrelevant. Tuples may be stored in uh, not in a clear manner. See here, ID is double two double two two is there. After that 1 to 1. So which is not in a proper manner. So definitely it creates some ambiguity. Ambiguity means confusion. It creates
Confusion.
some, yeah. Next one is dad. For that example, you can see the example for that. So ID is there, name is there, department name is there, salary is there. But if you observe salary, that also not in either ascending order or descending order. There is no proper order. So whenever you see either ascending order or descending order, if you see ascending order, your salary, you can see from lowest salary to highest salary. If you see descending order from highest to lowest, you can observe. So sometimes relations will be not in order. This is the example table for that. Next one is database schema. What is database? You have any idea about it? Do you
Database
have any idea about what is database?
which stores data.
Fine, very good. What is data now? Good. What is
Information.
data? No. Data and information.
Database is like organized collection of related data, no?
Okay. Very good. That is correct. I am asking about
Mm.
what is data. You said correctly for database, but I am asking what is data.
Data is like information.
No.
Um,
Data and
like
information both are not same. Both are not same. Data and information. Shall I give confirmation about it?
for example, like data is like my name is Ananya, like age 20, my branch. Is it something like that?
Yes. Okay. That is what correctly you said. Your name is
Okay.
Ananya. What is your course name?
Computers and communication.
Fine. Which semester you are studying now?
Both.
Okay. Fourth semester is information or data?
Data.
Fine. In the fourth semester, Ananya is information or data?
It's information, I guess.
Very good. Information gives confirmation. Data gives collection of raw facts. That is,
Okay.
see, fourth semester is the data. From the fourth semester, various students are there. So wherever I give confirmation a specific student name, that is nothing but information. Means the result of data is nothing but information. The processed data is nothing but information. Got it?
Okay.
Suppose horror movies. Horror movies means that is a data. In the horror movies, specifically, if you say any movie name, that is information. The result of the data. From the data only, information will get. You get information.
Okay.
Okay. Yeah. Database schema. Now we will discuss. So because of database, where you arrange all the data, that location is called database. Because of database, we learned database definition, data definition, and information definition. See, database schema, it is the logical structure of the database file. Physical structure of database means where you store the data, that is nothing but a physical structure of database. But the logically, what type of data you stored, that is nothing but database schema. Next one is database instance. It is a snapshot of the data in the database at a given instant time. At any specific time, whatever data is there, that is nothing but database instance. For example, if you see all the columns names, that is schema. By seeing the column only, you can identify what kind of data is there in the rows. Am I correct?
Hmm.
Yeah, that is nothing but database schema. See there, instructor, ID, comma, instructor is the name of your relation, ID, comma, name, comma, department name, comma, salary. These are the various attributes we have. These attributes tells what type of logic is there in your rows. See, observe that. Logical structure is nothing but a database schema. Logical structure means totally it identifies columns. Any doubt?
No,
Next, keys. What is key? What
I
is
don't know.
key? Which? Okay, no problem.
Like
Which kind?
candidate key, primary key.
That are examples. Basically, key is any unique information. Keys.
Okay.
What are the various informations are there? Now we will discuss. See, let K subset R. That means key is part of your relation. Key is available in the table. Key is part of your relation. Now, what is relation? Relation is a table. So, in the table, any specific row is nothing but, any specific column is nothing but key. Example, K is a super key of R if values for K are sufficient to identify a unique tuple. Unique tuple, any unique row, if you identify by using that column in any relation, that is nothing but key. Next one, whenever key is a super key, whenever by using one column, if you identify the row, that is super key. Super key is a candidate key whenever K is a minimal. Whenever you have limited columns, that is nothing but candidate key. ID is a candidate key for instruction. Instructor. Instructor is a table name. ID itself is the key. Here that is the candidate key. One of the candidate key is selected to be the primary key. So any one you can select as primary. Primary means main key. What is the main key? Yes, I want to tell three columns. Please confirm with me which one is the primary key. Okay.
Okay, okay.
Roll number, student name, student mobile number. These are the three attributes. Now confirm with me which one is the primary key.
Roll number
Yes, roll number is a primary key. Why?
because it is a unique ID.
Very good. Unique ID.
Uh,
Why?
Students can have the same name, but not the same roll number.
Very good. Perfectly correct. And one more point is regarding that. What is that? By knowing the roll number of a student, student can identify his total academic records. His total
Yeah.
academic records in the form of rows.
Mm.
That's it. That's why it is an unique. Next, see here, one of the candidate keys is selected to be as primary key. What is foreign key? Foreign key is any condition. Constraint means condition. That is a value in one relation must appear in another. Please understand here. Whenever you work with two tables, means two relations, one table attribute should be available in the second table. One table attribute should be referred in the second table. That is, suppose example, referencing relation, referenced relation. Two relations are required. From the two relations only, you can identify which one is the foreign key. Suppose one person, I am a citizen in the India. If I go to another country, am I citizen in that country immediately?
No, foreign.
Yeah, I'm a foreigner. I'm a foreigner in
Yeah.
another. Same. Here two countries we are taking same like that. Here two, but in the two countries person is same. Please try to understand relations logically. Tables,
Mm.
whenever you understand logically, then only you can get an idea about the concept. Here
Okay.
person is same. Places are different, but here one person is the citizen in one country, one person is foreigner in the other country. Same like that. For identification of a foreign key, we need to work with two relations, two tables. Example, department name in instructor means in any relation is a foreign key from instructor referencing department. See, let's see the diagram. Here we
Okay.
have university database. We
Mm-hmm.
have university database. If you observe here, clearly you can see first one is we have takes ID, course ID,
Okay.
section ID, semester, year, grade. Course ID is connected with again we have one more relation, one more table, that is section. Please observe here. In the section also we have various attributes. Now course ID is connected with course ID. Section ID is connected with section ID. Semester, year. These are the various. So in one table, that is a primary key. In another table, it will become a foreign key. Am I correct?
Yeah.
Yes. Next one. See here, room number. Basically, in college, one building is there. Every building consists various room. Every room has its own number just for identification purpose. Am I correct?
Okay.
So in the section, every section has different rooms. That's why room number is connected. Every section is located in different buildings. That's why building is connected with the building. Please observe classroom. Classroom I am talking. Classroom is the relation. Classroom is a table. So previously in building is one attribute is there. That attribute here in the classroom, it is a primary key. Whenever you go to section, it will become foreign key. Next, see here time slot. Time slot also one of the relation, one of the tables. So that is time slot ID is connected with the time slot ID. Why? Because every section has its own time slot. In every time slot, we have individual subject. Please try to understand logically. Every section has its own timetable. First one. In every hour, you have different subjects. Now see here, course ID. Course ID is there. Teachers. Why? Because every course taught by the faculty. Next one, section ID is there, semester is there, year is there. Same like that. Preparation requirements, one of the table is there. Another one of the tables, course is there. Course has different attributes, course ID, title, department name, credits. Credits are nothing but hours in a week. How many hours you have for one subject? So course ID is there. Course ID is connected with course ID. Next one, preparation ID is connected with that. So why preparation requirements are so important connected with course ID means based on your course title and your subject only preparation requirements are dependent. That's why these two tables are connected. Next one, student table is there. Every student has its own ID. That's why ID is the first name, department name. Every student is belongs to different department. Next one, total credits. How many total credits are there for one student in per 1 hour, 1 week? Next department has its name. Building, every department has its own building. So every department budget is there. So how like one table is connected with another table. So in one table, if one attribute is a primary key, in another table, whenever it references in another table, it will become foreign key in another table. That is advisor, student ID, instructor ID. Student will get advices, instructor also will get advices. That's it. How one is related with another one, logically you need to understand. That is nothing but a schema, logical structure. Any doubt?
No, sir.
You can write your own diagrams, student and faculty diagrams, department and building diagrams, or anything. But one table attribute should be depend on another table attribute. That is important. Any doubt, Ananya?
No, no.
Now see, relational query languages. So in the tables, whatever attributes are there, whatever tuples are there, how to question by raising the queries, how to get answers for that. That is nothing but relational query languages. See, procedural versus non-procedural or declarative. Non-procedural name is declarative. Pure languages we have relational algebra, tuple relational calculus, domain relational calculus. So three types of pure languages are there. The above three pure languages are equivalents in the computer operations. Now, in this chapter, we are going to discuss about relational algebra. It is one of the important concepts, relational algebra in the database, especially in the relational database, means a table related database. See, first one is relational algebra comes under the concept of a procedural language that has some set of operations that take one or more two relations. So you can apply these relation algebra operations on a single table or more than one table. That produces a new relation as their result. Please try to understand. If you take one table, you can apply relation algebra on one table. From that, you can get a new table. That is nothing but a resultant table. So you can apply these relational algebra operations on two tables also. Here tables are nothing but relations. What are the six basic operations we have? Select. Select is represented with sigma. Project. Project is nothing but pi. Union. Union purpose is just combining all the elements at one place. Set difference. Difference is nothing but minus. It is represented with minus. Next one is Cartesian product. Multiplication symbol, that is. Next one is renaming. How to rename the relation or any attribute. Select is nothing but by using that you can select your various tuples, various rows. That means sigma, where you are selecting rows. In the rows you are selecting. That's why sigma of R you are taking. Here P is there. P is nothing but in the base value P is there. P is called the selection predicate. Example, please see. Before going to discuss example, first observe here table. Select operation. Select means you can select any table name, any column, any row. That's it. Very simple. That name itself defines What is the purpose of that? ID, name, department name, salary. Please observe here. 4 attributes are there. So from that 4 attributes, please observe here. Your query is sigma department name equal to physics. So whenever you select department, physics means uh, physics related name you can identify, physics related ID you can get, physics related people salary you can get. Like that, you can write a query by using the select. Suppose I want to tell one more example for this. Sigma
Okay.
student name equal to Ananya.
Hmm.
Automatically, Ananya row will be displayed. Ananya tuple will be displayed regarding various attributes. Got my point?
Okay.
Suppose you are working in one company. In that
Hmm.
company, 60 employees are there. But I want to know only Ananya's details. What is the employee ID of Ananya? What is the salary of Ananya? What is the contact number of Ananya? What is the address of Ananya? So I want to know only that particular peculiar student. Just by using the select operation, you can identify that entire row information and column information. Got it?
Yeah.
So this select operation allows comparisons. Suppose what are the comparison operations we have? Less than, greater than, less than equal to, greater than equal to, not equal to. These all are the various comparison operations. That also you can identify. Next, we can combine several predicates into a larger predicate by using this. Please try to understand. Suppose Ananya and some other employee, 2 employees are having same salary. I want to combine same those who are having same salary by using and. By using and, I can combine. Suppose I want to give a work for 2 employees, either Ananya or one more person. So I can use or. I don't want to give
Okay.
work for any people. I can use not. These various operations also you can apply
Hmm.
by using select operation. Just by
Okay.
selecting, you can give one work for 2 people. So you and some other person, and you can give one work for only one person, you are or other person, and you can deny work for any 2 people.
Okay.
Example, find, see here, physics with a salary is greater than, suppose I want to apply one condition. Those who are having more than 60,000 salary, please, that people bring your salary status certificates or any statement. So just for income tax purpose. Like that also you can generate a query. See, by using my intention is by taking one table, by using rows or columns, you can apply any kind of conditions, any kind of condition. That is nothing but select operation. Select operation selects any rows or columns just for applying the condition purpose. Next, see here. To select the predicate may include comparisons between 2 attributes. You can compare 2 columns. Example, find all departments whose name is the same as their building name. Some employees are there, their names, and some buildings are there, that buildings names both are same. So here I am applying the condition, I am raising a question, whose buildings names are equivalent to employees names, please meet that employees. Like that also you can generate a question, you can generate a query. Suppose sigma department name equal to building. Very simple. Whatever you want, you just apply that column names or rows names by using the select operation. In front of that, you can apply the select operation. This is the
Okay.
procedure to apply any condition for rows and columns. Got my point?
Mm.
But here, small thing is there, just by applying your presence of mind, whatever row you are applying, whatever column you are applying, after mentioning that row and column, please immediately mention your relation name. Your relation name. Your relation name is nothing but your table name. Got it?
Okay.
That's it. Next one is a project operation. So suppose if you want work with any specific attributes, you want to project something. In that scenario, we are using project. A unary operation that returns its argument relation with certain attributes left out. What is the notation? It is represented with pi. You can apply any number of relations. A1, A2, A3, and so on, aka. These all are the various attributes in a relation. Attributes are nothing but columns. The result is defined as the relation of k columns get by erasing the columns that are not listed. See, projecting is nothing but which is an operation we are going to apply on the columns. Duplicate rows removed from the result. Suppose I want to tell one point here. Project hall ticket number, student name, again student name, student address. Here we got two times student name attributes are there. So it's here waste of your time, waste of your storage space. That scenarios you can apply project by removing one column. Next one, see here. Example for project operation. Eliminate the department name attribute of your relation. The relation name is instructor. If you want to eliminate that, very simple. Pi id comma name comma salary. You want to display only id comma name comma salary from where? From instructor relation. Now see the result. id, name, and salary. Only that columns, that related rows only will be displayed. Project means projection. Whatever you want to display, that will be displayed. In front of that, you need to apply the pi. Any doubt?
No.
So these are the various procedures you have. So just I want to give the demo. You can
Okay.
ask me. That purpose I said all this. So
Okay.
if you are interested, definitely let's continue from tomorrow onwards.
Who should I like contact and everything?
Come again. I'm unable to understand. Come again.
Who should I contact?
You can contact ma'am. Ma'am is who are connected, both of us.
Hmm.
You can
Hmm.
contact her.
Okay.
Ma'am,
Okay.
ma'am will contact you, I think.
Okay. Okay.
Okay.
Okay.
Okay. Thank you for your participation.
Yeah.
Okay. Fine.
Okay.
Okay.
So, I have a doubt.
Yeah. Tell me, please.
So, uh, uh, what is actually Cartesian product?
Yeah. Cartesian product is nothing but
Hmm.
how it is represented. Cartesian.
X.
Very good. X. Multiplication symbol. Simply we can say. Am I correct?
Yeah.
Very good. Suppose if you want to combine any two tables information at one place, from that you can generate new table. In that scenario, we are using Cartesian.
Okay.
Simply Simultaneously, you are comparing two things. One is one table, another one is another second table. From that, you can join new two tables, combining two tables simply, we can say.
Okay.
Got my point? Suppose student table is there, student ID, student name, student address. This is the student table. Next, second one is department table, department ID and department name. So here, student is part of your department. Student is dependent on the department. Am I correct?
Mm-hmm.
So you can combine both at one place by using the Cartesian product.
Okay.
That's